How about you? Good. Have you had a good week? Good. Good. Am I? How are you? You always need to get your souvenirs and get your souvenirs appropriate. Oh, you bid on it. Oh, good. I'm fine. We have a presentation so they get 12 minutes to bring back questions. Ring the bell. What castanets? Good morning, everybody. Great to see everybody still here um, on the last day of the conference. So this is the climate change session, which we only started a few years ago, and it sort of shows how we adapt to the issues that are most pressing in a timely manner. We had sargassum, we had
Recording
megafauna,
in progress.
and so now there seems to be a shift towards a lot of these more timely topics, and so I think that's good, and that's healthy, and it's responsive. So this is the climate change session, and I'm going to remind the speakers that they have 15 minutes total. They can use it however they want, if they want to sing for 15 minutes or dance. But they can talk for 12 minutes and then have 3 minutes for questions, and we're going to try to keep it on time. So in order to ensure that that happens, we've already gone over 4 minutes. So we will start right now, if I can open my app, with the first talk, and it is it's about Antigua and Barbuda's coral reef crisis. And you know, I don't have your name.
Yeah, it's not on the app.
Rulio.
Yes.
So Rulio is going to be talking about Antigua and Barbuda.
Good morning, everyone. First of all, thank you for being here on a Friday morning after cocktail last night. Really appreciate it. So, again, my name is Rulio Camacho. I'm the marine ecologist at National Park Authority in Antigua and Barbuda. And I'm going to be talking to you a little bit about hurricanes, sea temperature, and coral bleaching. So, just to kind of set the scene, a little bit of background about the National Park Authority. It was established in 1984 on the local legislation within the Antigua and Barbuda National Parks Act. The mandate is to preserve, protect, manage, and develop the natural, physical, and ecological resources and the historical, architectural, and cultural heritage of the site. So it is a completely self-financed, no government attributed budget, not-for-profit organization. We're quasi-government, so we do fall on the ministry. Has about 80 full-time employees, but less than 10 technical staff. We have a UNESCO World Heritage Site. The community that it involves is normally around 2,000 persons, but it swells to around 6,000 persons in the tourist season. So there's quite a bit of diverse stakeholders, and that plays a part in how we do management. And it really and truly is the center for yachting and tourism in Antigua and Barbuda. Tourism, which makes up over 60% of the GDP, right? So the area that I work in is the Nelson Dockyard National Park. If you've ever been to Antigua, this is the southern side of the island. It's actually only 40 miles from here, although traveling was a little bit more difficult. But there's a variety of marine ecosystems. It's 16 square miles total. 55% of that is terrestrial, 45% is marine, and it is a Category 6 IUCN. So it's a protected area of sustainable use of natural resources. It is not, it is not similar to like a U.S. national park or anything like that. It is a locally derived term, right? So we just want to set the scene with that. All right, cool. So coral reefs. Everyone knows why coral is important. And we started a coral reef restoration program with the aim to restore coral health while enhancing ecosystem services. And we were picking sites based not only on their ecological health, but also the socioeconomic influences, again, thinking about tourism and everything that happens in that area. And we started one in 2021 off of Hercules Pillars. And we're focused on aquaporid species because we all know aquaporids grow fast. We started doing outplanting early 2023, but the 2023 bleaching event, which I think to this date is the largest one that's been recorded in the Caribbean, reduced our corals to around 7%, right? So almost completely wiped out the nursery. And we've kind of focused more on repopulating with the species that have survived with the hope that they're more resilient, right? So that's where we are right now. We've been repopulating the nursery. In terms of coral bleaching and sea temperature, we saw bleaching in 2023 and 2024, and what we also noticed is that rapid tissue loss normally preceded bleaching, right? And I actually had several discussions with different persons last year about whether or not this is heat stress related, and we're seeing repeated signatures that I'll talk about a bit more. We record sea temperature from Hobo sea temperature loggers that are around 30 feet in the nursery on the nursery tree structures themselves. We currently have 4, so we have 2 MX2203s like what you're seeing in this picture, so this little thing here. We also have a light logger that records temperature, and we have a pH logger that records temperature. So we have replicability within the nursery so we can figure out making sure that we're getting a good average in terms of what temperature is doing. So now that I've set the scene and given you the background, I'm telling you what we're doing. Sea temperature and coral bleaching. So this is what we saw in 2022. So if you remember, we started recording sea temperature in June 2022, so this is why this date is not complete. But you can see here sea temperature spiked slightly in September, and then, but never got above bleaching threshold, and we saw healthy corals, right? The nursery was doing good, the parents were doing good, everybody looked good. Do pay attention to the 2 APAL species at the bottom. These are 2 of our parents that are referenced continuously going through this presentation. In 2023, complete different scenario. I want to point out a couple of different areas on this graph. So first of all, in between May and June, right, we did have spikes, but everybody looked good. That was the same parent colony I showed you from earlier. Colors were good, nursery systems was great, fine. In August, we started to see spikes going up to and then passing the bleaching threshold. And at that point, we started to see RTL in the nursery system, right? Very clear being linked with temperature that we're seeing. Then throughout the bleaching, throughout the October into November, we definitely saw bleaching, these two parent colonies again, paling on this one and quite a bit of mortality on the other one. And so we started to really keep notice. But we were hoping that this was going to be a one-off, really hoping that this was a one-time thing. 2023 was going to be that weird year, and we got back to, life as normal 2022. Then rolled around 2024, right? So, again, I want to point out a couple of things here. So in June, there's this weird spike. And at that point, once again, we started to record rapid tissue loss within the nursery systems. But that spike dropped, and actually, when we saw that spike first, we thought it had to be like some issue with the temperature loggers. But we had 4 loggers that recorded the same spike. We had another group that was on another side of the island that recorded a similar spike. That spike was very interesting. Then, mid-August, temperatures start to run up above 30. Again, we start to see RTL within the reefs. And then when you get September, you get maintaining above 30. The parent is doing fine so far, given besides the mortality I had from last year, but we're definitely seeing bleaching now within some of the nursery fragments. But by the time into late October, you're now seeing bleaching, throughout the nursery, and even the parents are starting to pale. So we started to, that kind of made us start to look at what's going on here. Is there really a linkage happening, or what's really driving this? And I started to look at storm impacts. So 2022, that spike, very interesting spike, that was Hurricane Fiona. Temperatures started to go up. Hurricane Fiona passed in 2022, and at that point, you saw a very big drop in temperature. That year, temperatures never got above 30. We had healthy corals. Everybody was great. 2023, we had temperatures rise continuously, get above 30 degrees. We had 2 storms in early October and late October. And if you notice, there's a drop after Tropical Storm Felipe. Temperature actually starts to go back up, and Hurricane Tammy passes, and it drops again. And so we're seeing signature marks happening, and that is when we stopped seeing bleaching, because at that point, we were recording like weekly, and we're just constant mortality throughout our nursery systems. And then those 2 storms happened, temperature dropped, and the bleaching ceased. 2024, 2 events are recorded, so everybody remembers Beryl. Now, there's an asterisk next to Beryl because Beryl did pass in the southern part of the Caribbean, and the signature relation isn't as close here, but, we're putting it in. And then there's another jump earlier as we're going towards 30, and that was Ernesto that passed Antigua. But notice we, at least in Antigua and Barbuda, we had no storms September, October, and so that temperature has remained high throughout, and that's probably what's leading to the heavy bleaching. So it really brings up the question of what does this mean for the future of coral reefs, at least from our perspective. So we're seeing a strong relationship between sea temperature, storm frequency, and the health of corals. Yes, we look at storms, and storms are typically a bad thing, but we're seeing some relation between two, and bleaching is both seen on the nursery as well as wild colonies. So we are doing looks at both sets. I'm just showing you pictures primarily from nursery and parent colonies. 2023 was the largest bleaching event that we had, but 2024 was unrestrained by storm activity. And so for the early part of the season in September, they were fine. A little bit of RTL and whatnot, but they were fine. These are corals that survived the bleaching event last year. But when you look at the data, this year's temperatures exceeded last year without the restriction of a storm activity, and this then drove extra bleaching. And the concern that we're seeing is that there's this rising trend per year over the last 3 years from the data that we have. Now, we have no 10-year, 20-year subsea surface temperature data set, so I do recognize that I'm speaking from only this view. But it's very interesting that what we're seeing. And the question is, are storms the key to the survival of Caribbean reefs? It's a weird thing, and no one is ever wishing for a Beryl, a Irma, a Maria level storm, but the tropical storms are also having strong impacts on sea temperatures, and we're seeing that that's helping with coral reef health over time. So is it now that we need to start wishing, hoping, praying, doing the storm dance, whatever it is for storms in August, September, and October? Because this year, while we didn't have any, and from an infrastructural perspective, that's great, the reefs didn't feel great, right? Like I did a dive my dive computer at 40 feet, I had 91 degrees Fahrenheit. Right, so this is temperature distribution throughout the water column. These temperature loggers are 30 feet. It's not like a light issue. I am not sure I want to put all my eggs into the basket of storms, so we're going to just toss that idea for a little bit. But I'm going to end on that note. This is a grandfather-parent colony. I actually saw this colony from about 10 years old. It was a single hand, scrolled over time. A little bit survived 2023, 2024 wiped out the rest of it. So she's completely gone. But it's one of those things where maybe we do want storms, and it's just, conversation. So thank you.
Thank you, Rulio. Do we have any questions? Mike has a question.
Yes.
Is there a good, strong relation between the observed sea surface temperature and the 30-foot temperature?
So we actually have nothing on the surface. And we have around the island, there's no data buoys or anything that's monitoring on the surface. What I can tell you from just observational basis is that from my dive computers, there's a 2-foot layer also at the surface that's always very warm, especially once, there's no activity. But it tends to, once you get down below the water column, it's a little different. We thought about moving the nursery systems deeper also, but we're recording similar temperatures, anywhere from 15, 20 feet down to 40, 50 feet, right? But I can't speak directly to that because I have nothing at the surface at the site that I can do a direct comparison to. Yeah.
Mark's up.
2. Yep.
Does somebody have a microphone besides me?
Congratulations for your presentation.
Thank you.
More importantly, for your work. So this kind of initiatives that we are in the region needed to better understand the effects and the responses from the natural disasters on natural populations.
Mm-hmm.
So my comment that I may like to make to you is if you have monitored not only hurricanes or tropical storms, but there are also throughout the year several phone calls or other weather events which can have similar effects. Not necessarily we need to look on for hurricanes by itself. And another thing is that perhaps we will need a few number of hurricanes, but if you have too many, that's another story.
Fully agreed. And just to say, so we do the water quality monitoring at this site also. It's part of it's one of our most pristine sites. One of the things that we have thought about going back into the records and putting with the data is rain events, and whether or not that could also, there's signatures that could be picked up from that, and that's a conversation that we hope to have with the Met Office and see if we can put exact dates and just input them into the data and see how that impacts it. But yes, I agree. This is why I'm very cautious about I'm not saying storms are the key, but there definitely can be some benefits from them, especially given that we can't do anything to restrict ocean warming at this point. And it's just very interesting to know whether or not there are similar observations being made other places. So, yeah.
We have time for one more question.
There's a hand.
I was just going to, I guess it's follow-up to her question, but I was just wondering, you had other downward spikes of cool events in the data set that weren't attributed to storms. I was wondering if you knew what those were.
No, and that's one of the things where, again, this was kind of, we saw the 2023 bleaching event. We very clearly saw the storms pass, and you could physically feel the difference in water temperature. And that's when I started to, okay, let me go back to the records, when are the storms, and just put them into the data, just without saying. It has now led to the question of there are these other weird aspects going on, and this is why I'm curious about rain events or swell events where you have large waves coming through, that kind of stuff, and maybe trying to input those also to see what signatures that's having with the temperature data and how that has an impact. So it is something that we've looked at. This is just at this point storm data, but I really do take your point.
Thank you. So actually, I'm going to take the prerogative of the chair of the session to ask you a question. I still have a minute. So it's the models now, the global models are saying that they think that the Bermuda High is going to shift more to the east, which would direct the Cape Verde storms more out to sea. And there's also the downscaled models that are saying that there should be drying in general, less rainfall in the Caribbean, which would both argue for not having the storms that you talk about or the rainfall and fresh water. So I just wanted to throw that out there. And do you have any comments? Any more comments? You've got a half a minute.
Again, it's the bleaching and the warming sea temperatures. There's a lot of things that I think as coral reef managers we can manage, right? You can manage pollution theoretically. You can manage pressures. You can manage physical degradation from anthropogenic aspects. The problem is that you can't manage sea temperature. And so it's one of the things where we've seen the largest impact on our reefs right now, besides diseases, which is a whole nother conversation, has been temperature. And they're very clear signatures. So it's how do you look at that and how do you manage a system if next year is going to be warmer than this year? So, you know, that's the scary part where I look at it, is the corals that I thought were going to be fine this year started to bleach, right? And that's what we're putting our eggs in because we had nothing else. If they now bleached, then what's a good time? I'll just, before I walk off, say just one final good note. We have found APAL that are still doing well in the wild. We're not finding cervicornis no more that's doing well in the wild. But there are APAL colonies that seem to be surviving. And it's also another interesting note that, you know, I'm just curious, and someone can reach out to me after, but whether or not you're seeing similar things where all cervicornis are all suffering at this point, but there are APAL colonies that seem to be fighting, so, yeah.
Okay, that's great. Thanks,
Okay.
Julio. Okay, our next talk is for Brian Walker. I've known Brian for a long time. I'm anxious to hear his talk because he's going to be talking about the poleward migrations of tropical fish, I believe. So, Brian.
Thank you. Good morning, everyone. Thank you for coming. Je m'appelle Brian Walker. J'habite en Floride. Voilà, that's it. No, but I'm here to present some work that we recently published with a master's student of mine not too long ago. I hope you find it entertaining. Anyway, if I put you to sleep, I just wanted to give you this up front so that if you wanted to have access to this paper, you can go ahead and click the QR code and it will download for you right now. And I also have this available at the end of the talk. Right, so throughout Earth's history, biological systems have been closely associated with environmental change on multiple spatial and temporal scales. A critical component of this association is the capacity for species to shift their distributions in response to tectonic, oceanographic, or climatic events. Pardon. Recent warming climate has provided opportunities for tropical species to inhabit new areas towards the poles, shifting subtropical and temperate communities along with them. I'm not used to this. Recent studies have documented many cases of this happening throughout the world in marine environments. A study showed 138 peer-reviewed papers from 2004 to 2023, where there were cases of either communities with tropical species increasing or temperate species decreasing over time. The consequences of this are drastic and many, which I don't have time to go into now, but some of the more drastic ones would be community phase shifts in certain locations, expanding species ranges, parasite introduction, changes in fisheries catches, and ecotourism. 3 models have been proposed for the outcome of a temperate reef community that is becoming tropicalized. These three down here below, given the current state of coral in most of the world, this outcome is probably becoming less likely, and we are seeing a lot of turf-dominated communities. So the factors that control assemblages vary along latitudinal gradients, and they've long been identified as zoogeographic indicators for large-scale distribution and diversity of many coral reef fishes. The ecotones along these gradients where faunal latitudinal ranges overlap and transition zones between biogeographic provinces, the species commingle in these zones to various extents, depending on the shifts in oceanographic climate and seasonal changes, local conditions, and ecological processes. And in general, you see a decrease in the number of species as you go towards the poles from the equator. However, this trend is now being changed slightly with climate change. But determining the reef fish tropicalization of a subtropical and temperate reef is challenging because many species ranges are latitudinally expansive. Their distributions are correlated with depth. They temporally shift with movement of isotherms, and a myriad of density-dependent factors affect their distributions. So to avoid these complexities, some studies focus on just the occurrence of a vagrant species in a new location through time, like this example of the black sea bass in North America. This is its original range, and now it's been documented to overwinter in those locations. However, in most systems, tropicalization is reflected in the relative density of historical and co-occurring species with wide-range distributions. And given the many factors affecting the assemblage, this can be very difficult to detect, and a baseline analysis is needed to measure any change over time. So you can see here, if this was the original assemblage, some of these fish will have no effect on increasing temperature. Others will have drastic effects in the middle. And then, of course, we don't know what temperature does on all of these processes that are happening that actually result in the outcoming assemblage. So this study was used to try to attempt to monitor or set up a baseline monitoring for tropicalization in Southeast Florida. We utilized extensive monitoring data along a known tropical to subtropical gradient, and we also wanted to use benthic habitat maps to spatially represent the fish assemblage zoogeography. So here's the setup. This is the Southeast Florida. The Florida Current, which is this dark line, is a western boundary current that travels along the mainland coast of Southeast Florida and transitions from a subtropical into a temperate environment. But it carries the tropical waters northward and out to sea where it becomes the Gulf Stream. This current has been long recognized as a gateway to facilitate the distribution of western Atlantic tropical fishes. This stupid thing. Whatever. Come on. No. Pardon. I don't usually use these. It's terrible. So in general, the setup is that this is a subtropical to a more temperate environment. We have the Gulf Stream that's coming up. And right here at this geological feature known as the Bahamas Fracture Zone, the geology of the coast of Florida kind of gives way to a wider shelf as you go north. And this wider shelf is allowing for the meanders in the Gulf Stream to create cold water upwelling, which is controlling the northern distribution of tropical species along our coast. And so this has been evident in analysis of benthic habitat maps, where if we look at the spatial variation in benthic habitat maps along the coast, we can define 6 ecoregions. So this study utilized 1,652 sites from 2012 to 2014 NOAA NCREMP data. These are stationary point counts where divers go down and count fish in an imaginary cylinder for a given amount of time. These were stratified random across habitat, ecoregion, and topographic relief, and ultimately counted to about 283,000 fish of 25 species from 66 families. So it's a pretty significant data set. Previous work of mine in the region has shown clear differences in the depth component with reef fish assemblages, noted here by these dark circles versus the gray and shallow. And also abundance and richness have correlated with many topographic metrics. So we wanted to capture all of these aspects in the analysis. So we characterized all the sites by 4 characterizations, whether the site was deep, occurred less than 10 meters, or shallow, or opposite, occurred greater than 10 meters or not. If it was in one of the 6 ecoregions, whether it was a hard bottom site or a coral reef site, and whether it had greater than or less than 30 centimeters maximum vertical relief at the dive site. Multivariate analysis of species densities by site showed a significant interaction between habitat type nested with ecoregion, depth, and relief on the reef fish assemblages. So basically all 4 of those factors were significant in shaping the assemblage. So an analysis of the data set, this is a bootstrap means plot of the multivariate analysis, and basically the distance between these circles are indications of their similarity to one another, showed distinct patterns in the data set where all of the deep water assemblages are plotted on the north side, all the shallow water assemblages plotted to the lower side. And then we also had eco-range patterns where the southern assemblages plotted down here and the northern assemblages plotted up here. There are also other differences between whether it was hard bottom or coral reef or high relief, low relief. So we took those data and we programmed them into the GIS to illustrate the locations of the assemblages based on the benthic habitats, because these that's the derivative of this analysis. So you can actually project the habitat maps as fish assemblages. And this really helped indicate where the transition zone, this Bahamas fracture zone, seems like a major difference maker in the region. So in total, this is just one example of a comparison between the different assemblages. I can't remember if this is the shallow or the deep, but it shows all the species here and their densities shaded in blue. But basically it showed that the southern assemblages had a higher occurrence and density of tropical species, and the northern assemblages had more subtropical species. There was 108 species exclusive to the south and 35 exclusive to the north. And richness was significantly lower in the northern regions by 5 to 10 species. If we look at the contributions, the relative contributions of the species differences between the assemblages, in this case these are the shallow assemblages, and this is the north, and it goes down to the south, and these assemblages show trends of species where, say, the doctor fish or the pork fish have a really high impact in determining the assemblage in the north, and they drop significantly throughout as you go south. So they have much less determination of that assemblage in the south. You can also notice that the number of species that comprise the 90% similarity are much higher in the south than they are in the north. And then we see the opposite trend with tropical species, where tropical species in the north are quite low in their contributions, but then they rise significantly higher in the south. And these are the patterns that we need to look at to understand the differences in tropicalization. This is also just illustrating the deep assemblages as well. So ultimately what we've found is that the Bahamas fracture zone is a really defining moment in terms of the differences between species tropicalization being able to move further north because of this cold water upwelling. However, the Florida current has recently been shown to have slowed by about 4% in the last 40 years, leaving in question about how long this cold water upwelling is going to be able to inhibit further tropicalization to the north. So making this study pretty critical. So the tropical species poleward expansion is expected to show homogenization or differentiation of the assemblage regions from their baselines. And then we would expect to see more southern species contributions in the more northern assemblages over time. So that's our future goal, is to look at the newer data sets in the same manner to determine if tropicalization has indeed occurred since 2012 and 2014. And this is just a summary of what I just told you, so I think I can skip that. And acknowledgements, I thank all the funders and the people that helped with this project. And you can, if you missed it, you can have the QR codes to my lab or to the paper. Thank you.
Thank you, Brian. We have time for one quick question.
It may not make sense in a room full of tropical reef ecologists and throughout the Caribbean, where you may not have these latitudinal gradients, but these types of analysis still may be relevant in determining changes in your local communities as temperatures get hotter and hotter.
Following that line, I think that for us here in the Caribbean, especially in the Antilles Arc, the most significant change will be the vertical distribution, and those shifts might be extremely significant. Do you have any comment regarding that vertical shift?
I do. I don't think it's, I haven't come across any studies looking at that throughout the Antilles. I do know there's studies off southern Brazil, you know, moving further south. Right now, the focus is going from tropical to temperate instead of these within ecotone changes. But yeah, I'm sure there are effects. They're just masked with many other effects. So that's the challenge. Yeah.
Thank you, Brian. You have 2 seconds.
Thank you
No,
for
that was
having the
great.
conference here. I appreciate it. It has been a great trip.
Great. Glad you liked it. Thanks. So our next talk is going to be by Maria Villalpando. Okay. From the DR. And she'll be talking about orthographics, which I'm anxious to hear about.
Thank you. Hi, everyone. Good morning. I'm very grateful to be with you all here. My name is Maria Villalpando. I'm the Research and Development Manager for the Dominican Foundation of Marine Studies, Fundemar. Today, I'm going to talk about how we used orthomosaics to assess coral bleaching impacts in Bayaibe, Dominican Republic. I know another sad story about coral bleaching, but I do believe it's a very important story to tell and to keep telling until we can. Oh, before I move on, I really want to recognize my co-authors for making this work possible: Rita, Sergio, Michael, Rommel, Rachel, and Aldo, who have put a lot of effort into this work. First, I want to give you a brief context of the history of massive bleaching in the Caribbean. We know we've had 3 major massive bleaching events in '98, in 2005, and 2010. And these events extend across geographies for long periods of time, affecting a wide range of coral species, and often leading to massive mortalities and also coral disease outbreaks. We measure this thermal stress as degree heating weeks, as you can see in this map from NOAA. This was the bleaching alert for October 2023. This was the longest and worst ever massive bleaching event in geographic extent, duration, and it also impacted remaining coral populations that had survived stony coral tissue loss disease. And that's why it's named the 4th global massive bleaching event. And here, just a little zoom to the alert levels in the Caribbean for October and November. And in the Dominican Republic, we also experienced this strong, long-lasting heat wave that's still going on today as we speak, that has led to thermal stress, massive bleaching, and mortality. Actually, before going into this one, we knew this was going to happen, and Dr. Aldo Crocker, knowing this, he established experimental design that was replicated in space and time to make sure that we were able to properly assess the impacts of this bleaching event, where we basically used SFN to monitor coral communities in 3 sites in Bayaibe. So the rule of 3, we love number 3, 3 sites. In those 3 sites, we had 3 plots that were 3 by 3 at each site, and we used 3D models and orthomosaics to follow them through time. We went every 2 months, starting in June 2023, so we have 6 sampling times. Afterwards, we constructed models at high resolution for these plots. This is our study area. We're in the southeast Dominican Republic, within the Southeastern Reefs Marine Sanctuary. This is the beautiful town of Bayaibe. If you haven't been, you should go. It used to be a small fisherman village. Now it's highly touristic. We have over 33,000 visitors per day or more. So a high volume of people, boats, that will likely have some impacts on the coastal marine ecosystems. Still very gorgeous, still go. We will give you some tours there. So these are our 3 sites close to Bayaibe. But today, I'm only gonna talk about 1 plot in 1 site. If you had worked with 3D models, you know they take some time to process and to analyze. So for this presentation, I will only be talking about the results from 1 plot in 1 site. And this is our little plot. We monitored 44 colonies for 1 year in this plot. Like I said, we went every 2 months to take pictures. So in 2023, we went in June, September, November, and in 2024, we went in January, March, and May. We measured in each of those time points the percent of healthy tissue and pale and bleached portions of the colonies by species, using ImageJ to get the area of healthy and pale and bleached. And we also calculated the disease frequency by species. And then we constructed the 3D models. We always like to make them dance. So you can see the movement. And out of these models, just like that. And out of these models, we calculated structural complexity using the rugosity index, dividing the 3D area by the 2D area. So first, I'm just going to show you visually each time point to see if you can spot any differences. So they are ordered in time, 1, 2, 3, 4, 5, 6, and here it is. So you see some bleaching, paleness happening in these time points, still on the 3rd one, and then you see some, sorry for the white balance going off in some of them. But basically you see recovery, you see large colonies remaining, but you do see a lot of loss of small, abundant colonies, like porites over here, like agaricids, and we can see that in the data too. So first, I just want to show you a transition so you can maybe see this more clearly from the first time point in June 2023 to the last time point in May 2024. Good. So now to the results. Here we have a bar plot showing the temporal change in tissue condition in the colonies monitored. In morado, in purple, you have the pale and bleached tissue, and in green, you have the healthy tissue. Here in the first time point, we have 100%, and you see that that goes down with time, also because we had other colony conditions like stony coral tissue loss and other diseases, but also because there was mortality through time. Bleached tissue varied from 17.3 to 16.5%, reaching a peak in September of 2023. And by the end of January in 2024, that bleached tissue had died. We had an overall reduction of only 2.6 live coral cover within 1 year. And here we have another bar plot of the temporal change of percent of dead and alive colonies. So total, you can see in these first 2 time points when bleaching was at its highest that there was no mortality. So this shows us that the mortalities we've seen is associated with the bleaching event. Total mortality was 52% by the end of the study period. There was a giant leap in mortality after 6 months in January, most likely after having the highest thermal stress and colonies that were not able to recover. It has remained stable after March, but currently these same colonies are withstanding another thermal stress event. Here we have a heat map standardizing by the bleached and dead areas by species. Basically, the redder it is, the darker it is, the most likely that it was bleached. Some of them, after here, were already dead, for example, in the case of cervicornis and porites. These yellow values just means that they were lost after some time. The only ones that remained were Oryzella violata in these cases. But we can see that the species that were most susceptible to bleaching and mortality was Acropora cervicornis, Agaricia agaricites, the Poritis complex, and Oryzella fabiolata. And the species with the highest tolerance was Montastrea cavernosa here on the top. They did not bleach, they did not show signs of paleness. Those are the true monsters, the ones that are the strongest ones. And here we have the results from rugosity. Here we have the loss in rugosity index, the change in rugosity over time, and it shows a dramatic loss, even though we did not lose a lot of percent live coral. We see about 50 to 70% loss in rugosity in 1 year. Over here we can see also the percent loss. This is likely associated to the 52% mortality of the colonies. And while the largest colonies remained, a lot of the smaller abundant colonies, particularly the agaricias and the porites, were lost, they died, and they detached, which really affected the structural complexity of the plot. And by this, we can see that the bleaching event not only produced mortality, but it also reduced and changed the features of the habitat in a very short amount of time. So conclusions and take-home messages. 2023, as we have seen throughout this conference, was the worst and the strongest bleaching event ever recorded in Valladolid and likely across the Dominican Republic. We've also had these efforts replicated in other regions in the country, and hopefully soon we can collaborate in a study showing those impacts at the national level. In our plot, we lost almost 50% of the colonies by the end of 2023. By only losing 2.6% of live coral cover, we lost 70% of rugosity in less than 1 year. So those small losses that we're having, and actually we're having huge losses, change dramatically features of the habitat. A formal analysis will be done using all the plots from all the sites to test the extent of the decline associated with this bleaching event in southeastern Dominican Republic. That's it from my part. Thank you so much for your time and for listening. I want to thank the French Embassy that sponsored this trip for us through the Monitorea project, and as well as my co-authors. And thank you all. Thank you to the organizers, and congratulations for this great conference.
Thank you, Maria. That was very interesting, especially the large boulder-forming corals, which actually form the reefs.
Yep.
In general, seem to be the most resilient, so that's hopeful. Does anybody have any questions for Maria?
Hi, Maria. Excellent work, thank you. I was curious about why you think that bleaching would have caused a 70% reduction in the rugosity.
Yes, because we saw that in the first 2 time points where there was still no loss from the bleaching event, there was no mortality. And then throughout time in that year, we lost species like the one that you see here, like, it's not there, like Porites, like Agaricia, the folios, the ramified colonies, all of those were lost in the plot. And even though they don't cover a great area, like the balding corals, like Orbicelas, they do provide a lot of structure to the reef. And all of those died, detached, and are on the, I don't know if we can see like the last time point. Back. So here, you see everything detached and was just on the reef floor. So it flattened the plot. There's another question here and here.
Thank you, Maria. Great presentations. Congratulations. I read your second conclusion, which for me is the most striking one. You have a comment. We still look at coral cover as an indicator of health, as an indicator that tells us what we should do in terms of management across the Caribbean. Do you have a thought or a message about using only coral cover?
Yes, I do. Thank you, Aldo. Yes, basically, it's been used throughout different protocols as a reef health indicator, and it's very valuable to follow it through time. But we can also show that there are other very important variables that we have to follow through to see the actual impacts and changes at the ecosystem level, like structural complexity and rugosity, which changes the features of the habitat. We also need to assess function of the ecosystem, and not only following coral tissue or coral cover through time can tell us what's happening at the ecosystem level. Thank you, Aldo.
One more question, Mike?
A related note, so I'm a 2D guy, I guess, by training, and yeah, it's kind of alarming to see how much information is different between the 2D view and the 3D view.
Yeah.
How intensive is the protocol? You mentioned it briefly, but what's kind of the difference in level of effort in doing this kind of 3D view versus traditional 2D plots or 2.5D plots?
It takes more processing time. It's very fast to do it in the field. We only have to do 3 dives, 3 like 20-minute dives to take the data. And then in the office, it takes a larger amount of time. Also, taking into account that you need a powerful machine. But now we have a new one that hopefully we can get one of those models run in 1 day. So I think it's related to the technology that you have access to be able to process this. But when you have it, I think it's very useful. It reduces time and cost in the field and eventually on land. But just having those images, it's already very valuable to see changes through time. I hope I answered your question, kind of. Thank you.
Thank you, Maria. I'll just add one comment. For many, many years, there's been an issue related to quantifying lobster habitat in coral reefs, and mostly related to how do you measure rugosity. And so this step is a really important move forward, and hopefully it will address not only coral cover, but also a number of other species.
Yes, beyond corals. Thank you so much.
So our next talk is actually who I was thinking of when I was thinking of who's going to be singing. It's Jack Johnson. I'm sure you get that a lot. Yeah. He's going to be speaking about Little Cayman, and the relationships, I guess, between coral bleaching and fish assemblages.
Yes, I was going to talk about fish assemblages, but we never got round to analyzing those data. So this will be another quite depressing talk on the coral bleaching that occurred in Little Cayman last summer. And I'll try and fly through it quickly because I want to also talk about hurricanes and what happened this year if anyone here has questions about that. So first, I want to say huge thanks to all these people that contribute to this tremendous effort that it takes for us to do all these surveys and analyze these data and collecting these data, and particularly thanks to the Darwin Plus scheme for funding me to come to this conference and show you our results from the bleaching and some other stuff. So briefly, for an overview of like how Caribbean coral cover has changed over time, we know that we sort of were around 40% coral cover back in the 70s and the 80s. That was our sort of regional baseline. And then because of anthropogenic activity, so disease, pollution, overfishing, and warming, this coral cover has sort of dropped to around a mean of 5 to 10% throughout the Caribbean. For example, disease was the most critical one. If people were diving back in the 60s and 70s, I'm very jealous of you. Apparently there used to be fields of acropora that existed, but these clearly got wiped out by white band disease. And then since in the last decade as well, we've had the emergence of the novel disease such as stony coral tissue loss, and this has further changed the composition of coral reefs and the coral cover to be even lower because, for example, diseases like Skittle D, they actually target your thermally tolerant species, right? So if it's getting warmer and you wipe out all these thermally sensitive corals, a disease comes in and it will wipe out the remaining thermally resistant corals because they are susceptible to disease. And disease in itself as well is also exacerbated by ocean warming, so it's sort of this feedback loop that becomes critical to corals. The key example of this is what people always put in their presentations and you always see in the media, is the change in somewhere like Discovery Bay throughout Jamaica, where you have these fields of cervicornis that just got absolutely eradicated in the last 40 years because of the combination of all these stresses I've just mentioned, and the same with Carey's Fort Reef, for example, here. But the biggest threat to corals in the 21st century is probably mass coral bleaching, because this occurs at an entire reef scale, and it can cause mortality over an entire reef scale as well. We saw that with the Great Barrier Reef, for example, during the back-to-back bleaching event in 2016 and 2017, and people have previously spoken about it just in this session throughout the Caribbean as well, with last year's heat and this year's heat too, where you guys in the Eastern Caribbean have actually been hammered a lot harder than we have in the Central Caribbean. But what about Little Cayman's corals? We're kind of a unique system in the sense that we sort of remained regionally high. We've kind of been hitting around 25 to 30% mean coral cover throughout the last 25 years. I mean, this is obviously likely lower than your sort of 1960s baseline. But generally, the coral cover in Little Cayman and the composition of species is really nice, and if you've not visited, I recommend you go do it as soon as possible before the rest of it gets killed off. And one of the main reasons for this is Little Cayman is a very well-protected and isolated island. So the high levels of protection have mitigated any local stresses. There's only 140 people that live full-time on this island. I'm fortunate enough to be one of them. So the local impacts are negligible. So there is, really low fishing pressure, there's really low pollution. 55% of the island is in marine parks, and these are very strict marine parks. And the fishing protections are very strict as well. Here we go. And most critically for Little Cayman, in my opinion, is we've actually been sheltered from marine heat waves. So I've just got this graph of the thermal history of Little Cayman in degree heating weeks for you here. And before 2023, we have never had more than 4 degree heating weeks. So 4 degree heating weeks is the threshold where mass coral bleaching sort of tends to occur. And then once you get up to 8 degree heating weeks, that's when you expect to see mortality of your corals, right? And we have never exceeded 4. So a lethal bleaching event has not actually occurred in Little Cayman since we started collecting these types of data in the 80s. But then 2023 came along, and it was the hottest year on record. All the records for wildfires got smashed. Hawaii was burnt to the ground. There were so many hurricanes throughout the Atlantic, and there was obviously a global mass coral bleaching event. And that was our degree heating weeks in 2023. We reached 18-degree heating weeks after previously never exceeding 4. And when you think about this from like sort of ecological standpoint, this means that all the corals that have existed in Little Cayman have never been through a stress event, so there is no acclimation or adaptation of any of the coral species to occur. So when the temperatures ramp up like this, it's even more severe than somewhere, for example, which has a thermal history which is like mildly stressful. So to give you an overview of how all the corals did, this is all corals combined. At the peak of bleaching, over 90% of all corals were either bleached, paling, or dying. And this occurred around October. That's when our maximum bleaching occurs, the hottest part of the year for us in Little Cayman. But by January, when we were doing our final surveys to assess mortality, over 55% of all of our corals in Little Cayman had died. And when you break this down by sort of functional groups or morphology or life history traits, so for example, we've got weedy corals on the left here, such as your agaricids. Over 75% of our weedy corals were eradicated by this thermal stress event. But on a more positive note, the thermally tolerant corals actually did really well. This Colpophilia natans I've got down here, this one actually died. These ones probably did the worst out of our tolerant corals, but for example, our orbicellas and things like that generally did okay. And this is an overview of all the species with their maximum percent of bleaching correlated with their maximum mortality. So you can see generally nearly all the corals bleached besides your Dichosenia and your Pseudorastrias. But the ones that suffered extensive mortality are your things like your Agaricias and your Porites, whereas your big reef-building boulder corals such as Pseudoastris ideria and Orbicella, they generally did okay. While they suffered 100% bleaching, they did not suffer mortality even though we reached 18-degree heating weeks, which I think is a good sign, but also indicates sort of how Caribbean reefs have changed and will continue to change even in places like Little Cayman. And this is just an overview, again, of the previous plot but shown in a different way to show you the composition of corals in Little Cayman. So you can see over 40% of our corals are actually Agaricea with the color, the deep purple color on the plot here. But you can see that 98% of these Agariceas actually died from the bleaching last year. So this sort of shows us how the thermal stress event has killed off all these weedy corals and has changed the composition of our reefs. And lastly, we saw this threefold decline in coral abundance. So we laid out permanent transects throughout Little Cayman and revisited them every sort of week and a half and every 2 weeks. And what we found was up to 300 corals were found on transects at the start of our surveys. And by the end, we were down to 100 corals still alive per transect. But one sort of really noticeable thing is we had no acropora on any of our transects or at any of our sites which we surveyed. So we wrote a grant to the British government, the Darwin Plus Local Scheme, who's funded me to come here. And the grant was to essentially just look for acropora to see if we've got any left, because it's a super important species for us. We need it for our nursery to do all of our experiments. And our nursery suffered 98% mortality last year. So we've only got an Acropora cervicornis nursery, and this is how it looks with these fragments growing on the frames. And we had 8 genotypes of corals, 5 of which were completely eradicated. 1 genotype had about 1 fragment left, and 2 genotypes were just hanging on. So our nursery got absolutely hammered, and we really, really, really do need some cervicornis to be able to keep most of our work going on. So what we did, we exhaustively surveyed all the dive sites around Little Cayman. So these red markers here are the mooring buoys for all the dive sites we can go to. We didn't go to the east end, that's the no dive zone. We didn't get a permit to do that. So we did 2 roving surveys. At each dive site, we did drift dives all along the north wall from the Penguins Leap site you see there in the northeast corner, all the way down to the west point. And this encompassed a variety of reef habitats. So on the north side, it's sort of this, it goes out seagrass to a reef crest, and then it's hard pan, and then you just get this nice wall and a sheer drop-off. So actually not an ideal habitat for your cervicornis or your palmata. But on the south side, it's a lot more sloping, and there's a lot of spur and groove, and a lot of ideal habitat for these types of species. But our findings were incredibly depressing. There were no live Acropora palmata at any of our dive sites. At 30 dive sites, we found dead palmata, and at some of them there were just fields of both old dead and recently dead palmata. Up at Mary's Bay, which is the northeast corner of the island, there used to be about 40 colonies I knew there last year. They were all completely dead. For the wild cervicornis populations, I generally knew where most of these big colonies were before last year's heat wave, and we went back and visited them. We only found 2 fragments, probably about that big, across all 65 dive sites that were still alive. And we also conducted probably about 400 recruit surveys to look for any babies we could find of Acropora, and we found no recruits for either species in this genus. So, in summary, these reefs have likely permanently changed, like many of your reefs from the Caribbean already have. This is both in terms of coral cover and composition. We have recently just done our long-term monitoring surveys in August to see how it's changed. These data are provisional, but I can tell you we have gone from 25% coral cover last year down to 9% coral cover this year. Again, no Acropora found at any of those sites, despite our long-term sites normally having them. And kind of to emphasize what everyone else has always said throughout the last 30 years in the climate sciences, there's kind of only one viable option to prevent such catastrophic damage to these reefs, and that's to stop the cause of decline, which is by targeting climate change. Thank you.
Thank you, Jack. I was wondering if you had any comments. You said you were going to talk about hurricanes.
Yes.
So I'm anxious to hear what your thoughts are on that.
So, as depressing as it is, I completely agree with the first talk that hurricanes really help corals in the Caribbean now, because we don't have these branching species anymore, do we? So the hurricanes don't rip them up and destroy them. They just cool the water down to keep the reef cooler. And we saw that this year with Beryl, where, when did she arrive? It was June or July, wasn't it? 1st of July. And we were already exceeding our bleaching threshold back in June this year. And then Beryl came ripping through and brought the temperatures back down, and we didn't warm up again till August. And without Beryl, I think this year would have been as catastrophic as last year. Well, I don't know.
Hi, Jack. Thanks very much for the work. MPA Connect does have Little Bloody Bay as one of our priority sites, or Bloody Bay and Little Cayman as one of the sites. And I think your research took in the MPA. Did you have any interesting comments for us, or anything to report in relation to the marine protected area?
In terms of how it protects the corals, or?
Yeah, any differences versus other sites around the island?
No, there's no difference. When it's a global stressor like this, as important as marine protected areas are, and I'm a strong advocate for them, and I'm so glad Little Cayman is 55% protected, when you have such an overwhelming catastrophic stressor come in, it really doesn't make a difference, because Little Cayman generally isn't that stressed out as well anyway. So the sort of benefits you get from an MPA from an ecosystem function perspective is still not enough to mitigate any sort of damage from something like 18-degree heating weeks.
Okay, thank you very much, Jack.
Okay.
We'll move on to the next.
Okay, you
talk.
afterwards. Thank you, guys.
Thank you. So our last talk of the session is going to be by Lalo. Everybody knows him now as the new chairman of GCFI. And don't anybody leave after his talk, because we'll probably have 10 minutes or so where we can actually talk about some other things related to all of this. Try to get some positive news out of it.
Well, good morning, everyone. My name is Eduardo Bonemoron, but everybody calls me Lalo. This is the formal name of my presentation, but I'm glad I'm the last one. I heard some words like depressing and bad news, but I think I would change my presentation to just hope, and let's continue to working together. I think we have the science, we have the political will in some places, and just let's continue working together. I think there's lots to do. So I'm going to change the title of my presentation to hope. The reason I'm presenting a little bit of an environmental defense fund is I want the people in this room to know what different organizations, including EDF, is doing, not just in oceans and marine conservation, but also across other disciplines. The mission of EDF, we're a US-based organization, but I think this mission really resonates with a lot of you. We're trying to preserve the natural systems on which all life depends. So this is an invitation to really collaborate with EDF and all the institutions here. So when we are done with this conference, please take everybody's emails and connect and work together. We're over 1,000 collaborators across 30 countries, and we have 4 programs: climate, ecosystems, health, and oceans. I represent the oceans program, but really one of the key messages of my presentation is how we're truly trying to integrate these 4 programs and make marine conservation and fisheries management possible. The Fisheries and Oceans program was created in 1996. We've been around for a long time. This map here shows all the countries where we work. Those numbers show the global catch that represent each country. And the work that we do in the Caribbean is very important. It's mainly small-scale fisheries work. And that really helps us, it serves us as a lab to understand what are the challenges, what are the opportunities for the small-scale fisheries, and translate those teachings to these other countries. I'm going to talk to you today about the work that we do in the Bahamas, Belize, Cuba, and Puerto Rico. I had the pleasure to work with some of the people that are here in this conference, and some of the work that I'll be presenting, you're part of that work. So again, this is an invitation. You see something that attracts your attention, please come to me and let's work together from a regional perspective. But EDF and GCFI have a long trajectory of collaboration. Myself, I've been collaborating with EDF for 7 years, and that's one of the reasons why I want to become chair. I'm so excited and honored to be part of this, and we really want to continue really creating those bridges across regions. Dalila, in her keynote speaker presentation the first day, she was showing this graph that was really interesting, showing how many publications we have at GCFI and how small collaboration is happening across different countries. So again, this is an invitation to continue working across countries. So this is the Caribbean initiative. What I'm going to be presenting you is EDF is taking another approach where we're not just working with very specific silos and just specific countries, but really trying to create this holistic approach and working regionally. And these are the things that we're doing to create this regional approach. I'm going to start with the Bahamas. Again, I'm only the infantry. Behind me, there's a whole cavalry. There's a lot of the work I'm presenting here, of course, is not only me. There's a lot of people behind me. In that picture, Seb Haukibo, some of you know him. Seb was coming with me as well, so I'm representing Seb on this one. Some of the work that we're doing in the Bahamas is strengthening this capacity to predict hurricane impacts on communities. So we're deploying low-cost sensors in fishing vessels to really train and work with the fishermen to collect data, empower the fishermen, and use that data to really understand what can happen in the future and how actually they can be proactive about getting ready for hurricanes. Krista Sherman was showing more of this amazing work. So we're working, we're mapping and restoring some mangrove creeks and really monitoring and identifying critical habitat to prioritize reforestation efforts in the Bahamas. And with that, we're doing this with technology, but also with a lot of hands and eyes on the water. We had a really great exchange. We brought Cuban scientists to the Bahamas so they could exchange and see how mangrove restoration can improve in these two countries where mangrove cover is really amazing. I love this program. It's about training young men in the Bahamas. We're trying to have like a tri-national program where we're training people in the Belize, in the Bahamas, in Cuba, and really it's just like, okay, let's work with young people, and fly fishing, that's the catch, and then we just promote all these conservation practices, and it's just a great way to engage the younger generations. This is also really exciting. So we're working with universities, with some private enterprises to equip fishing vessels with electric motors. This is part of the work that we're doing, connecting the work that we do with the oceans with the energy transition work that EDF does. I'm really excited. I'm going to be working really closely with this project in the next 2 years. So pretty much we're just like trying to understand what are the potential to have electric powered motors for fishing vessels for multiple benefits. And part of that is also training fishermen on how to fix those motors, how to track, actually monitor how much energy we're saving with implementing this technology. Belize. That's actually, I took that photo, that my friend Nick Requena is right there. So one of the work that we're doing in Belize is same thing. We're really mapping, identifying key habitats that currently don't have any type of protection. So we can act now and work with the authorities, work with co-management. Some of you know the great work that Belize does with co-management. So working with the communities is a big part of this work. And we're using that information to also inform management and really help authorities to direct efforts in these multi-use marine protected areas that Belize is so proud of. Puerto Rico, as you know, Puerto Rico has been hit pretty badly. Puerto Rico hasn't recovered yet from hurricanes, so EDF is working really hard. I don't know if you had a chance to be in a presentation from our colleague Emmanuel Maldonado from Puerto Rico. He was talking about Culebra. Culebra is a small island, a fisheries island, and so we're aiming to have Culebra being the first solar-powered island in the Caribbean. We're getting there. So very proud. We the next 3 years, you'll be hearing about Culebra. So keep an eye on the news. Cuba. So I'm the senior manager of the Cuba Oceans Program. I had the pleasure of working for 8 years in Cuba. EDF has been in Cuba for 25 years. Some Cuban colleagues are here in the room. That work wouldn't be possible with our Cuban colleagues. And I'm going to talk a little bit about the work that we're doing in ecosystem-based adaptation. This is a project that is called Resiliencia a toda costa. I love the logos that Cubans create. This is a great one. So this map is showing the 4 protected areas that we're working on with 9 vulnerable communities. It's a 3-year project. We're coming to an end now in February 2025. We're working with 11 institutions. And I'm going to present you a little bit about the 3 objectives that we have. The Caribbean Biodiversity Fund is funding this work. We're presenting a new proposal to continue building upon the great results of this project. And so the project has a strong component in alternative livelihoods. Aquaculture, I want to have macroalgae, sponges, fish, oyster. We're creating a network of experts on these topics to really understand what is the potential and implement pilot projects in these 4 protected areas. That's Yadira. She's holding some oysters in Baracoa in the eastern part of Cuba. Restoration, we're doing sexual and asexual reproduction. We're actually working with the colleagues from the Dominican Republic, learning a lot from the Dominican Republic folks. Thank you for all the great work. We're taking all that knowledge to a good use. We're restoring seagrass beds, mangroves, and coral reefs. And monitoring, we're monitoring ecosystem health, we're monitoring biodiversity in all 4 areas with community involvement. Capacity building, really capacity building is probably the most important part of this work. As you can see in this photo, we included one of the kids. The workshops, we call them open workshops for the communities. We invite managers, scientists, but always make sure that we invite kids and the families so they're part of these capacity buildings. And communication. Communication, we are really trying to create lots of different materials for different audiences. And we're going to be creating videos, and we're going to be creating some of this. Well, I'm going to be talking a little bit more about this type of products that we're producing. Cuba mapping the future. So in 2023, Cuba just embarked in probably the most ambitious marine expedition on recent history of Cuba. So during 2 months, 25 Cuban scientists circumnavigated the island to really understand the status of coral reefs and other marine life. And of course, this overlapped with these heating events. So really the researchers were seeing how the coral reefs were bleaching as they were like one day they were monitoring, the next day the coral reefs were gone. So it was really amazing to see that happening. So these are some of the numbers that we came up. We are going to, I love this photo. This photo, it's that's the fish, the coral reef group. We had 13 different groups on the boat, microplastics, marine mammals, birds, fish, sharks. So all together, working together to create new science and sharing science. We're going to be publishing 13 articles in a special edition of the Bulletin of Marine Science, where we're going to be showing, it's going to be December 2025. Actually, we're thinking about having a special session at GCFI to present some of these results. If somebody's interested, this is also another invitation. We don't want this to be just Cuba specific, but I think we would love to have a special session about hope, what's happening, what's actually possible, so we can talk more about how we can create and share that knowledge. Very importantly, el bojeo a Cuba, bojeo, by the way, it means circumnavigating. It's apparently a word that is very common in Cuba, but I've never heard about it, but that's what bojeo means. El bojeo, it's really there's a study that shows that there's 50 reefs across the country, across the globe, that have some hope. 4 of those countries have been identified in Cuba. So one of the things that El Bojeo is trying to do is really highlight how these coral reefs that are in Cuba have the potential for the genetics, the development, the conservation, the management to actually help other coral reefs across the island. So it has been really a diplomatic and scientific tool to collaborate, not just in Cuba, but across the Caribbean, and also take all the information across the world. And of course, we're using this information to guide conservation and management. President of Cuba, Manuel, I'm sorry, I'm blanking. Susana, can you remind me that I'm so sorry. Miguel Díaz-Canel, I'm sorry. He invited EDF to where some of the organizations were, some of the most important organizations working in conservation, and really Mr. Díaz-Canel acknowledged the importance of El Bojeo and how that information can be actually implemented for conservation and management. We have what we call the Learning Network for Sustainable Fisheries. We have a capacity building program. The shirt I'm wearing, that's from a university course on sustainable fisheries. We have recruited 70 professionals, and this university course has really led the way to have Cuba presenting the first multi-species ecosystem approach, ecosystem-based approach proposal for quotas for finfish fisheries, which is a lot. We're very excited that this capacity building has actually gone into that direction. We have the ambassadors. The ambassadors program is people that have the knowledge, have the tools to go back and replicate the information that they're getting through all these capacity building activities. You can see some of the kids right there. And outreach, we just create videos, pamphlets, games, to really make sure that people have the tools to implement all of this knowledge. Thank you so much. And again, I look forward to collaborating with you. And hopefully we have some questions here and outside the room. Thank you.
Thank you, Lalo. Lalo's like our Sting or our Bono. He's a one-named, a person with one name. So we've got like 5 minutes left. Do you want to take some questions? Or we can start a discussion? Because I have a point I want to ask everybody, and don't move. And that is, has anybody started to see any adaptive capacity being, or adaptation in any of these coral communities where previously they might have bleached or died, and they're now starting to either recover or to survive well? And if so, if there are conditions that are associated with those? Has anybody seen that? I think Maria mentioned that she has some that are surviving.
Thank you. This year we had a new paper out led by Margaret Miller from SECOR, where we found in Mexico, in Curacao, and in the DR that the recruits that we produced through assisted sexual reproduction were 2 to 6 times more tolerant to heat stress and bleaching than conspecifics. It might be due just to their juvenile stage, but none of them bleached, and they are all still there. They have other pressures now, since they're mostly what's on our intervention sites now. They're getting predated by snails and have some macroalgae growth and stuff like that, but to bleaching they were very, very resistant. We are starting to see a lot of recruitment, right, Aldo?
Yes, that is correct. Throughout the northern coast of the Dominican Republic, there are a couple of sites we have been seeing with amazing and outstanding recruitment rates. There is a place nearby Puerto Plata Airport in Sosúa. It's a reef flat with, pavement, and you see not only high numbers of recruits, but what surprises is the number of species that are recruiting. And these animals are like 2 to 3 centimeters, 4 centimeters, so that means that they have survived the stony coral tissue loss disease that was very strong there, and also the bleaching event, as Maria was mentioning. I saw the same in Jamaica, so I believe that we are very good at recording decline, but we need to put an eye on recovery as well. We need to start doing recruitment studies, and and also restoration using sexual propagation.
Basically, the children are the future. Thank you.
One thing I've heard throughout the talks this morning and other places is we're looking at a very critical metric of mortality in corals, right? If they bleached, if they died, or if they recovered. But there's a lot more to that story. And studies coming out now looking at fecundity effects of a bleaching event the year before turn out to be quite critical into how fecund those corals are as to whether they bleached the year before or not. And so it's just not a matter of live tissue cover, color of the colony regrowing, but all of these bleaching events could be having lasting effects on the reproductive capacity of these corals. And so I urge folks who are working in this field of bleaching to think about that and encourage you to also do histology and look at those reproductive effects.
Does anybody have any more thoughts on that? I think the last time we were in Guadalupe, the person who gave the keynote address was Dirk Zeller from University of British Columbia. And he made the point of you know, at some point we have to sort of pivot from watching and the way he put it was, watching the rivets pop off the ship and start actually trying to rebuild the ship. And so, you know, there's this, sure we could monitor all the corals dying, but, you know, we need to find some clever adaptation approaches that can really, you know, restore either the ecosystem or the ecosystem services. At least that's my opinion. Does anybody have any? Martha?
Yes, it's been decades since we have been changing in the fisheries management perspectives. So changing from top-down approach towards a little bit bottom-up approach. And I see that as important collaboration because nowadays fishers, at least in the case of Puerto Rico and perhaps other places in the Caribbean, trust more the scientists and provide them whenever they saw a special event. Either this is a rare species, even if they found in their stomachs when they clean the fish, so they bring those individuals to scientists. So that in the way we are able to, at least informally, have this network on communication with the people that are every day at sea. They can notice changes more quickly, and maybe that give us some ideas how to pursue and respond to this new information coming from them. Thank you.
Anybody have one final thought?
So just in terms of the presentation before and speaking about hope, what I will say is that what we're seeing is that there are, despite that we had higher temperatures and despite that, you know, we didn't have storm impacts, we are still finding corals that are surviving, that survived longer in warmer waters than they would have survived last year. We've seen outplants that have survived. I mentioned at the end of my talk that we did a scouting experiment, and we found apal colonies where we didn't think they'd have been surviving, but you know, you're still finding some. So yes, I do think there needs to be innovative approaches if you have the capacity to do sexual reproduction and do experiments. But also sometimes what I'd encourage the persons who are doing primarily field work is search in areas that you may not expect to see things in, because sometimes it'll surprise you. Like sometimes there are areas that'll surprise you. And what I find is the corals are trying, we just have to make sure that we're not additionally adding stress, pollution, degradation, you know, poor ecosystem management, etc. And control the things that we can control, because they will try, right? But we have to make sure that we're doing our part. So there are some positive signs, not as much as we want, but I think it's important to do acknowledge that there are some positive signs out there.
Thank you, Julio. I'm going to use that term, the corals are trying. That's a good take-home message, I think. So I want to thank everybody for coming to this session. I want to thank the speakers for being on time and having provocative things to say. And Nancy Brown in the back has an important... I'll repeat it after... Oh, here comes your microphone.
This has nothing to do with climate change. So if you bid on an item and have not picked it up and paid us, you have half an hour. And then if you don't come and get it, the next person up will get your item. So please come and help us clear out this table. Thank you.
Thank you, everybody. Next session starts at 10:30. It'll be invertebrates.